The last few days we've been looking at patterns in bubbles or charts or numbers, anything like that. Now we're going to be looking at sequences now. So connections representation, okay? So what we're going to connect visuals to expressions. Why? So that way to think like mathematicians, to use mathematical structure to connect two things that look different. So think about it like this. You can look at a picture or draw out 500 circles and be like, here's the number 500. Visually, there's 500 circles. But wouldn't it just be easier to write the number 500? Yeah, I think I'd rather write the number 500 than draw out 500 circles. So think about that as we go through. It's kind of, I wouldn't say a cheat sheet way, but sequences are an easier way to express what's going on with algebraic thinking, okay? So we're going to look at these equations. So remember, these are linear equations because it's in y equals mx plus b form. So my first equation is y equals 6 plus 3x, and my second one is y equals 6 plus 2x, and then my last one is y equals 6x plus 2. So we're actually going to look at these equations visually. So I want you to take a second, pause the video. Which equations match both of these two here? Which two equations match these patterns written out? So now that you've had time to think, what we're going to do here is we're going to look at these little patterns. So I know that at this point right here, I have 6 circles. And then I have 3, 6, 9 circles. Then I have 3, 6, 9, and 12 circles. Well, what's happening? Well, I know that I originally started with 6 circles. And with those original 6 circles, I added 3 more on. And then after that set of 3, what I did is I added another set of 3. So can you guess which equation this would be? Right, it's going to be this first one right here. Because it says 3x plus 6. I originally started with my 6 circles. And each time that I increase the amount of 3, it's going to get larger. So this essentially would be 3 times 1 plus 6. This would be 3 times 2 plus 6, because there's 2 sets of 3 here, extra from my original 6. So take a second, write it out, jot it down, however you'd like. Now let's start with the second one here. Which equation do you think it's going to be? Well, let's see how many triangles I actually started out with. I started out with 6 for this one. So I started out with my original 6. And I'm going to put a square around my original 6 so I know what's happening. As it's increasing, what is happening. So from here to my second grouping, I actually have 8. 6, 7, 8 triangles. And with that original 2, I add another set of 2. So I'm at 10. So which equation do you think it's going to be? Y equals 6 plus 2x or y equals 6x plus 2? Well, it's actually going to be the middle one right here. Again, each time I originally started with my 6 triangles. For the first one, I started with 6. So that's where this 6 comes in. And each time that I'm increasing my triangles, I'm adding 2 more, or multiplying by 2. So this essentially is 2 times 1 plus 6. 2 times 2 plus 6. Because I have 2 sets of triangles. 2 sets of 2 triangles each time. So I want you to take a second and actually think about, what do you think y equals 6x plus 2 would look like? Now that you've thought about it, let's move to the next slide. So ask yourself, how are the visuals different And how are the functions? So the functions are going to be y equals something, an equation essentially. How are they different? What are the chunks of the functions? And what are chunks of the visuals? So what the question is asking, how are the visuals different? Are they different? And how are the functions different? Well, the visuals provide us with a visual representation, such as this with the circles and the triangles. While the the function, we can see is straightforward. It's y equals 6 plus 3x or something like that. So as you're thinking and jotting down, what are the chunks of the functions and what are chunks of the visuals? So for our next slide, we're going to create a representation. And I want you to ask yourself, what are the chunks of the expressions? Okay, so actually we're going to go back to our original equation. We said, what the heck is this? Y equals 6x plus 2. If we were going to recreate it, this is what it would look like. So our y-intercept tells us how much we're starting out with, in this case, squares. You could have drawn triangles, you could have drawn circles, but I like to keep things consistently different so that way when we reference back, we're not going, which circle equation? That way they're all different. So I know that I start out with 2 squares. And each time that I add to my set of 2 squares, my original 2 squares, which are going to be right here, I'm adding 6 more to them. So if I took 6 times 1 plus 2, that would be 6 plus 2, which would be 8. So that means this first one right here is actually going to be 8. So if I keep my original amount here of 6 plus 2, which would be 8, and I add another set of 6 onto it, so that's 2 sets of 6, I'm going to get 14 squares, which is shown right here. So as you can see, the pattern here, it's increasing each time by a consistent amount. So now what you're going to do is we're going to work on the handshake problem. Okay, so today we're going to be creating a situation where we hypothetically are going to shake hands. Everybody's hands in class, so including us teachers. So if you're either virtual or in person, obviously we're not going to get up and shake hands because, hashtag COVID, and how are you supposed to shake hands through the computer? But hypothetically speaking, if we were going to shake hands with every single person in your WebEx or your classroom, how would this work? How many handshakes would we exchange? So you're going to brainstorm some ways that you can approach this question and describe it or illustrate it on your paper. Okay? A hint that I would suggest to you is maybe write out everybody's name in class, including us teachers. So obviously I wouldn't say that Miss Stiles is in my classroom because she's in virtual and vice versa. So I want you to take a good about 5, 10, 20 minutes, and I want you to actually think about, if I was going to shake hands with Miss Stiles, that's one handshake. And if there's another person in the room, that means my hand and Miss Stiles' hands shake together, and I shake the other person's hand, and they two shake each other's hands, and we all shake hands. So similar to Tuesday's lesson where we are looking at the connections with Facebook. Think about that situation and start thinking of your ideas. So go ahead and start working. So there are several different ways of how to approach this. This is the way that us teachers have approached it, and you don't have to go this certain way. But as you can see, I am here at the top, and I have a circle, which is a little bit more visually helpful for us to see who I'm going to handshake and who's not going to be handshaked. So I'm going to go over first all the online kids. So you is Miss Stiles or yourself. If I was going to shake everybody's hand, or Miss Styles is going to shake everybody's hand in the WebEx chat, she would have shaken 26 hands. Okay, so now Aylin is going to work, and it's going to be her turn to go around and shake everybody's hands. So hers would look something like this, added onto it. So if you notice right here, there's no green line going to Miss Styles. And here's why. They already shook hands. If she would have counted for her count of 26, shaking hands, or sorry, 25, shaking hands with Miss Styles, that would be double counting. And nobody likes to double count. So if it continued on and on with all of the students in your class, eventually you would move to Alba, and she would shake hands with everybody except for Aylin and Miss Styles, because she already shook hands during Miss Styles' session or handshake. So again, it would just continue on, Aaliyah, and so on and so forth. So we would get super crazy. So essentially, the person or persons before you, you're not going to shake their hands. So if I went all the way down to Hunter here, he is basically going to shake hands with Isaiah, Jameson, Jocelyn, Karina, Carla, Brianna, and everybody else after him. Sorry, it's super small and I can't read it. So he's going to shake hands with everybody before him, and vice versa. He's not going to shake any of the other hands over here because he already shook hands with them. They already shook hands with him, so he doesn't have to shake back. So for the in-person students, it would look the same way. I would shake hands with everybody in my classroom. So Connor, Steven, Chris, Jaden, Jose, and so on and so forth. So if Connor was going to shake hands with everybody else, again, he would not shake hands with me because we already exchanged handshakes, and so on and so forth. And it would just get more crazy with Steven, and then Chris gets involved, and he's shaking everybody's hand after him, but not before him. Okay? So let's actually look at this in numbers. If person 1 shakes everybody's hand in the room, that's 26 handshakes. If person 2 shows up or starts shaking hands, that's going to be 25 handshakes plus the other handshakes from person 1. So basically, our number is going to get to 25 handshakes because person 1 already shook hands with person 2. We don't want to double count. So we're going to add together the handshakes from person 1 and their handshakes. Same thing with person 3. There's 24 hands being shaken because person 3 already shook hands with person 1 and person 2, so we're not double counting. And we're going to add all the one amount from the previous 1 and 2, and so on and so forth until we get to person 26. And in-person case, that would be Mabel. She'd basically be shaking hands with nobody because it would be full. Same thing with William. He already got shaken hands with everybody. So here's the cool thing about this. That's a lot of numbers. If I was going to add 25 plus 24 plus 23 plus 22 plus 21 plus 20 all the way down or up until 26, all the way down to 1, that would be a lot of handshakes. So in this case, we can actually create a formula that'll help us find it to the nth number of sequence. However many people in the room, I could find 100, I could find 200, anything like that, with this simple equation. N is the number of people. So if I have my number of people, so let's say 26, I have parentheses, and I'm going to do 26 minus 1. So 26 minus 1 would be 25. So essentially, just like with the Facebook one, I'm multiplying 26 times 25 and dividing it by 2. If you recall, the reason we divide by 2 is because we want to cancel out the double handshakes. So now that we actually know the formula, get ready for your checkpoint.